We're here looking at Unit 2 motion quantities. And to kind of begin this, I'd like to ask this question. This was a question that was asked to me in 4th grade on a math test, and I got this question wrong. We'll see. We'll see if I still get it wrong. The question I was asked, though, was if you're walking your dog down the street and you walk 3 blocks, so you walked 1 block, 2 blocks, 3 blocks, and then you walked 3 more blocks, how many blocks did you walk? And the answer you're looking for, most people are like, hey, if you walk 3 blocks and you walk 3 more blocks, you would walk a total of 6 blocks. That's an easy one, bots. Like 3 plus 3 is 6. But I said that you walked 0 blocks, because you walked 3 down this way, and then you walked 3 back to where you started, and therefore you didn't go anywhere. And I got that question marked wrong in 4th grade. And I thought I gave a very, very clever answer. Well, it turns out that it's just, in a way, a bad question. Or maybe the difference between these two answers is what we're going to be talking about today. And it has to do, to begin with ideas of scalars and vectors, which lead us to positions and distances and displacements. Okay, so what is a distance? What is a displacement? What is a scalar? And what is a vector? So to begin with, a scalar is something that just has a value. Okay, there are 7 apples. There's 7 of something. Okay, you weigh 115 pounds. I ate 8 bikes. I don't know how I ate bikes, but I ate them, okay? Like, these are things. They're quantities, but they're scalar quantities. There's just a magnitude. There is just a size to them. A vector, on the other hand, not only has a size, a magnitude in amount, like a number, but it also has a direction it's going. So if you said, hey, I was biking down the street at 15 miles per hour, well, were you going north, south, east, west, northeast, northwest? Like, which way were you going? So you're going 15 miles per hour northwest. That has a magnitude and a direction, making this entire quantity a vector. So a vector is something that has a size and a direction. A scalar is something that only has a size to it. Okay? So those are the 2 differences we're going to talk about here. And we need to understand the idea between a scalar, something just having a quantity, and a vector, something a quantity with a direction, when we talk about distances and displacements. Because distances, by their definition, are scalar quantities, where a displacement is a vector quantity. And whenever I type things out, normally scalar quantities, such as a distance, which I say is delta x, or a change in your position. Delta x, the delta being a change in, the x being your position itself. If I were to write that out, I would just write that out as delta x. And on paper, whenever I'm typing it out, it's just in regular font. For vectors like displacement, when I type them out, you might notice that this here, this delta x, is bolded. Whenever I would write it out on paper, though, I'd actually write it as delta x with an arrow on top of it. And oftentimes you'll see me write this as just an arrow with one direction like that. It's a little faster writing this than it is doing that. But this is the direction here. Okay, so that is the direction. It says that this is a vector. Okay, it has both a size and a direction. So when we see me writing those out, that's what we're talking about, scalars and vectors. Now, a distance is just your actual length of travel. You can think of it as like, how many steps did you take? Okay, so if we look at some of these examples down here, and let's just go through these to do distances. We'll do distances in red. If we start at this point here, the 1, and we end at this point 4, we have walked along the number line just 1, 2, 3, right? So the distance we traveled was 3. For this second one here, we started at the 1 again, and when we look at our distance, we went 1, 2, 3 to get all the way out to the 4 position, and then we turned backwards and we continued to walk. We kept taking steps. So we walked 1 step, 2 step, 3 step, and then turned around and went 4 steps, 5 steps, 6, 7, 8, 9, 10. And it took us 10 whole steps to move across and then back. Here, if we go over by 4 and then up by 3, we had to walk 1, 2, 3, 4, and then we turned to the right and went 5, 6, 7. Even if this is a negative number, we still took a step in order to move through that distance, okay? No matter what, distances will be positive values, and you have to count every single step that you take because it is a scalar quantity. On the flip side of things, if we look at displacement, a vector, the only thing we care about is our starting point and our ending point. And when we look at our starting and ending points for our vectors, since we are looking for a delta x, what we're looking for is what is your final position minus your initial position here, okay? So where do you wind up? Where did you start? And that's it. That's all we care about. So if we look at our first example, we ended at 4, we started at 1. 4 minus 1 is 3. These happen to be the same answer, but they don't have to be. When we look at the second example, our final position is -3. -3 minus our initial position of 1, -3 minus 1 is -4. And if we take a look at this here, well, this is a little bit weird for our last example. Our last example, we just want our start and finish. So our finish position is up here, our start is here, which means I want this value, which that's a weird triangle. I just can't like count things. But luckily for us, we may recognize this to be a 3, 4, 5 triangle. So this actual distance that we've moved through here is a 5, and to get to displacement, it has to be in some direction. Well, on our first two, I could say that this went to the right, so it was positive, and this went to the left, so it was negative. This one's a little bit weird. Later on, whenever we start getting into vectors in Unit 4, we'll talk about exactly how to figure out what direction this is pointing, but in short, it is at some angle. And if we think about kind of a compass we have here real quick, where this is north, south, east, and I thought you said west. We can just say for right now that this is traveling in a northwest direction. But later on, we will see how to get an exact angle for which direction this is traveling at. Okay? So displacements are a amount, it's a change in position of the object from the starting and ending point. The distance is every single step along the way. Okay, so those are our two differences between distances and displacements. We want to keep these ideas of scalars and vectors in our mind. They're a little weird when we start thinking about them, but as we continue on in this class, we'll start getting better and better with them, and we'll be using a whole bunch. So this is a good first step for that. And with that, this is finished. Take it easy.